Uh-huh. Puns. I just said the same thing to Jack a few minutes ago. Okay. So, guys, determine if the sequence is arithmetic, please. Please follow along. Super important. Hi. Hi. If it is, find the term named in the problem in the explicit formula. Okay. So I can tell that this is going down 30, and I can tell that this is going down 30. But the question is this also going down 30? Is positive 19 to negative 11 down 30? Yes. Yes, it is. Yes, it is. Okay. So each of these is going down 30. So D equals negative 30. Okay, now we need to find the number in front. So we need to go up 30. What's up 30 from 19? 49. T0 equals 49. Okay, arithmetic sequences are T of n equals D times n plus term 0. Think of it as y equals mx plus b. We've done this, by the way. This was chapter 5. Why are we doing it again? You'll see. Okay, now it says find term 26. So we plug in 26. The term 26 is negative 731. Does that look like it's a reasonable thing? If we continued it out, yeah, because it's got a 1 at the end. Okay, 216, I'm going to say 4, 9, 16, 25, 36, 49, 64. I'm going to put my little list over there so it's set for all 4 of these warm-ups. Okay, 216. Is it divisible by 4? Yes, but it might be divisible by more than that, so I'm going to keep going and check. 216 divided by 9. Ooh. 216 divided by 16. 216 divided by 25. 216 divided by 36. Ah, there it is. 36 and 6. Square root of 36 is 6, so final answer 6 root 6. Jules and Emily, a question. Are these the same warm-ups as in the previous videos? Okay. I would just say if what? Oh, I was just curious. If you come across something that isn't the same, I'm still gonna post the videos that I do every day so you could check those. Okay. Now, if you guys could please find this page. We're going to do this page as part of the classwork today, but we're also in the notebook, so we're in both. I know. Yes, we have. It's 8-2 and 8-4. Excellent question. All right, you guys, start by setting up these graphs, please, and thank you. I know, I know. I know. Hey guys, so chapter 8 is, I feel like, a lot easier than chapter 7, which is probably good. Um, and the first part of it, pretty much all of it, is about exponentials. So the reason that we're doing sequences is to remind you about things that add and things that multiply. Exponentials are the ones that multiply like times 3 times 3 times 3. So that's what this is saying right here in number 1. This very first graph is talking about what kind of graph do you get if you times 3 times 3 times 3. We ended our first semester with this, and we made dots that made a curve. So what I'm going to do on number 1 is I'm going to bring up Desmos, and then I'm going to enter in these 3 equations, and we're going to sketch them and talk about what's happening in each one. So there's not any math to do in number 1. We're just going to make sketches. The first one we're going to do is 3. Okay, and what I mean by that is y equals 3 to the x. Okay, there it is. So y equals 3 to the x. And we're going to sketch that in. And I want to be very careful about something when we sketch it in. We're going to try not to touch the x-axis. And the reason is this looks like it touches the x-axis, but it really doesn't. So if I take this, notice that decimal is getting smaller and smaller, but it's not 0. Okay, so what I mean by that is we're going to, yes, honey. Exactly. Okay, so what I want to do is I want to sketch it, but I want to leave the tiniest bit of daylight between the x-axis and my curve. This is called exponential growth. And what's happening is in the table, the numbers are getting multiplied by 3 each time. So times 3 times 3 times 3, which gets big really quick. That's why it's so steep. Okay, now we're going to see what happens when we have a multiplier of 1/3 instead of 3. So I'm going to go back to Desmos. And I'm going to change this 3 to be 1/3. And look, it's pretty much exactly the same graph. It's just decreasing instead. And I want you to do exactly the same thing you did before. I want you to come down toward the x-axis and then try not to touch it. It's hot. Don't touch. This is called exponential decay. You guys think about, what does the word decay mean to you? And the reason that it's called decay is actually a really nerdy reason. It's because, have you heard of anything called half-life, or radioactive decay, or carbon dating? That's where this comes from. So the amount of carbon in something that's dead has a certain time that it cuts in half. And so that's how you can go backwards and figure out when something was alive. It's really, really cool. Anyway, now let's see what -3 looks like, and it's really weird. How do I show it? It won't even let me show it. So, oh, there we go. It's so strange that I can't even get it to show what it's supposed to show. Okay. What's happening with the -3 is, you guys know what happens when you multiply something by -3. Okay, so let's just try it. Let's do what's 1 times -3? -3. And what's -3 times -3? +9. Okay, so what you're supposed to do is you're supposed to notice that this is flip-flopping sign. It's going negative, positive, negative, positive, negative, positive. We're going to attempt to sketch it. It's going to be hard. Desmos it's so hard, Desmos can't even do it right. I think my graphing calculator might be able to do it better. Hold on. Let me see if I can get that. Mm-hmm. Yeah, kind of better. It's just dots. Yeah. But do you see, this is a much better picture than Desmos was able to do. It's just sweet trying to help. Okay, anyway, so what we're going to do is attempt to sketch this dealio over here. So you're going to go negative, positive, negative, positive, negative, positive. That's terrible. Well, I feel like I've done better. Okay, and you see how weird this is. So the whole point of this is for me to tell you that we will not be studying this. This is not math 1 level math right here. This is so weird. I couldn't even get Desmos to do it right. So we will be studying these two, but definitely not this guy. But anyway, okay. I don't even know because it's not math 3. Anyway, no. Okay, now can you guys find that resource page that we were talking about? So number 2, we're going to go back to our resource page. And we're going to sketch in, so this is actually two problems. It's number 2 and number 4. In number 2, we're just going to sketch in equations and graphs. So this one says B is greater than 1. I suggest we pick 2 just for easiness purposes. So we're going to call this y equals 2 to the x. And I'm going to go back to Desmos and change that to a 2. Does it look that much different? No. Notice this spot, though, is really important. So if you guys could label the y-intercept 0, 1, come along the x-axis like we did before. Try not to touch it. And then go up and label that coordinate 0, 1. And this is the one that I was calling exponential growth. So we're going to circle this. And we're going to come around to the rest of this stuff at number 4. But for now, this is all we're going to do. Okay, now for the second box, it says choose a b anywhere between 0 and 1. And I'm going to choose 1/2 because it's easy. So 1/2 to the x. Okay, and notice it's coming down and also crossing at 0, 1. So it has the same y-intercept, but it's coming downward. So do your best. Try not to touch the x-axis. And this one is decreasing. This is exponential decay. It's going down each time because you're multiplying by half. And then a half of that, then a half of that, then a half of that, and then a half, another half, and then a half, and then another few halves, and then some more halves, and then half of that. Yeah, so many halves. Okay, now the next two are weird. Is 1 first? Yeah, okay. So 1 to the x looks like this. It's a line. And it also goes through 0, 1. But if you think about it, it makes sense because 1 to the 1 is 1, 1 to the 2 is 1, 1 to the 3 is 1, 1 to the 4 is 1, 1 to the 962 million is, yeah. So we're going to come back to our picture. Draw in our line, label our y-intercept, and I'm just going to go like this because it's not increasing or decreasing, it's just flat. And then this last one in the top section is 0 to the x. That one's also weird. So this one is not a function. It has two dots and then a line that goes forever to the right. Math is anyway. So we have 0, 1, and then we have 0, 0, and then array that goes off this way forever. Also not increasing or decreasing. And notice this one's not a function because it fails the vertical line test right there. Okay, now we already know these last two are going to be weird. This guy, we don't even need to graph. We know that it's going to do this flip-flopping thing, so just do your best. And it's both increasing and decreasing. Weird. Yeah, honey. Neither, because it's staying flat. Absolutely. Okay, last one on this page, and then we go back to the notebook. We're gonna do -2 to the x, but not in parentheses this time. And this one is a flip under the x-axis and it goes downward. So do your best to sketch this guy. And he is definitely decreasing. Okay, now go ahead and set up number 3, please. Yeah, on Star Wars. I mean, like, the first credits and they go back and they're all like tilted, or not the credits, but the story at the beginning. No one, Star Wars, nobody, nobody. It's fine. It's really okay. It's just like at the very beginning, they give you backstory, but they like tilt the font so it's like going away from you. And that's how like it looked on the screen, like it was tilted. Yeah, I don't know. I know. It's my nerdness is happening again. Okay, so now what we're gonna do in number 3 is we're gonna investigate why I want you guys to leave that little bit of daylight between the graph and the x-axis. Why do we not touch the x-axis? So that's what we're hoping to figure out in number 3. And I just picked one of the functions that we were working with, which was 1/2. We just did that one on our resource page. And I'm going to plug in these 3 numbers. The first one I'm going to do is 1/2 to the 5. Then I'm going to do 1/2 to the 10. And then I'm going to do 1/2 to the 1000. And I'm going to do those all in the calculator. Okay, so 1/2 to the 5 is 0.03125. Okay, that's a really little number. 1/2 to the 10. That's even a littler number. Okay, so remembering scientific notation, this means I need to move the decimal 4 spots. So 1, 2, 3, 4, which means there's going to be 3 zeros in front of the 9. That's an even littler number. What do you think's going to happen with the 1000? I think the calculator can't even do it. It's actually going to lie to you, tell you that it's 0, I think. Yeah, but it's not. Calculator just can't handle it. Okay, now because this gets closer and closer to 0, Mhm. How many E? E what? 102? So I need 301 zeros and then 999. Okay, so it's 9 point what? Give me the first three. Holy schmoly, that's a small number. Okay, so we're explaining the graph will get closer and closer to the x-axis, but will never touch it. This is called, does anybody know what it's called already? It's a fun word. It's a super, super fun word to say. You should go home tonight and say that you learned about this. The word is asymptote. You sort of feel like you're swearing at the beginning of the word, but you're not. It's like ass tote bag, like tote bag, asymptote. Yeah, in your tote. Nice. Okay. So what we're going to do next is we're going to make the table for 1/2 to the x, and we're going to graph it as best we can to show the asymptote. Okay, so I'm going to do 1/2 to the -2 is 4. 1/2 to the -1 is 2. What do you guys think is happening to the decimal? Happening to the y column? Let's see how many of these I can do. Okay, what's half of that? 625, I think, because 12 is 6. And then half of that, we already know this one because we did it a minute ago. Okay, I don't know what half of that is though. That's wrong. That's wrong. This is wrong. This is wrong. That's correct. I had too many zeros in there. But anyway, let's see what of this we can graph. It's going to be great. Okay, -2, 4. 1, 2, 3, 4. Okay, that one's easy. -2, 4. I got that one. Woo! -1, 2. Excelente. I can graph that. 0, 1. I'm all over it. Okay, 1.5. All right, all right, all right, all right. Yeah, still doing it. 2.25. Okay. Oh no. The decimals have gotten so tiny that we can't really graph them accurately. So we're just going to put little dotsies in that are approaching the x-axis but not crossing it. So just draw your curve in. Don't touch it. Try not to touch it. I'm going to see if I can do it. Oh my gosh, it's happening. Okay. Whew. Okay, now what I'm going to do is I'm going to come along with a red pen that's really going to anger the red pen. The red pen is not going to speak to me for the rest of the day. And I'm going to come along the x-axis and I'm going to dash over top of it with the red pen. This is the asymptote because the curve is approaching it, but never touching it. Okay, once you guys get your asymptote drawn in, go back to the resource page. We're going to fill in the rest of the things, and then we're going to talk about the weird stuff, and then we're done. The negative flip-flop business. We're just basically going to say we're not doing that. It's a nope. It's a hard no. Okay. Okay. First graph, x-intercept, none. Why not? Because it's never going to touch it. Y-intercept, 0, 1. Okay, blast from the past. What's the domain? When you ask yourself that, does it go forever left and forever right? Yes, so that means it's all reals. Does it go forever down and forever up? Forever up, but not forever down. So we say y is greater than 0, and we don't have the or equal to on there because it's not going to touch it. And the asymptote is the x-axis because it's getting closer and closer to the x-axis, but not crossing. Okay, now a lot of this is going to be repeats. X-intercept, none. Not going to touch it. 0, 1. Does it go forever left and right? Yep, great job. Because it goes forever up. Yep. Okay, so really what's the only two differences? What's the only difference between these two? Mm-hmm. Mm-hmm. And how can you tell? Whole number, fraction. Whole number, fraction. Okay. These two. X-intercept, none. Okay. Still going forever left and forever right? Yes. Okay, but forever up and forever down, no. There's just a line. There's only one y value, which is 1. This one does not have an asymptote. Okay, this one's fun. It has infinite x-intercepts. They're all along here. And it has 2 y-intercepts, 0, 0, and 0, 1, which makes it not a function. Okay, doesn't go forever left. X is greater than or equal to 0. There's only 2 y values, y equals 0 and y equals 1. Now, if this is like super hard for you, don't worry. That's not what the chapter is about. The chapter is about the top 2 boxes. Yay. Okay, last 2 here, and then we're just going to write sentence for number 5, and we're done. X-intercept, none. Believe it or not, the y-intercept on this is still 0, 1. We're not even gonna bother with the domain and range on this. It's so weird. But it does have an asymptote at the x-axis because it's approaching it from both directions, really. Again, if this is really hard for you, don't worry. That's not really what chapter 8 is about. We're just on an exploratory mission right now. Yeah. This guy here, he will be in math 2. So x-intercept still none. Y-intercept is 0, -1 this time. Ooh. Domain is still everything left and right, but the range is, it's forever down this time. Again, if this is really hard for you, it's okay, because this is math 2 right here. Okay, go back to your notebook. We just need to fill in the stuff that we're going to give a hard no. Okay, in math 1. We are not going to study any negative number for B because the signs flip-flop and make this weird dotted thing. We're going to give that a hard pass. Okay, we're also going to give a hard pass to B being 0 and BE being 1 because those are just lines. So for our class, we're not going to have negative B's, and we're not going to have B is 0, and we're not going to have B is 1. The 2 top boxes on the resource page are the ones I care about. Okay, now, when you're done, can you look at the stamp sheet side? What's the homework, my people? 14, skip 13. Okay, and I do have a joke for you. Okay. We looked at different values of the base B. We did it. It's done. Homework is 7 through 14, skip 13, and it says, how do you count cows? With a calculator.